question that we were doing. We completed one question, right? And that was so this was what was the question? This was the question that we did the last time, right? And now let us understand, or let us do another problem. And we will draw one by one every components, and you guys will tell me that how to solve that question, right? Because that question is simple. So if we can draw the diagram, then rest of the things are pretty easy. So they become very easy if we write every forces. That is the idea of free body diagram, right? We select a point, and then on that point, we write every forces which are acting on that thing, right? So in free body diagram, what are the forces that we don't count? If we are writing a free body diagram, what are the forces that we don't count? Yes, anyone? Yeah, so I'm saying internal forces, not. What do you mean by internal? I'm not talking about intermolecular forces or all those forces, not that type of force, right? I'm asking about that. Let's say forces are acting. So what are the forces that we don't count in free body diagram? That is the question. Yeah, and
I think normal
yes, yeah.
force.
Normal force we always count, right? Normal force we always count. So we always count the normal force, right? But this normal force, yeah, you are partially correct, right? You are partially correct. So there are two kinds. The normal forces acts on between these surfaces, right? So this surface is touching this ground table or whatever this surface is, right? So there are two forces which are acting, two normal forces. One is applied by this thing, right? So there are two normal forces, right? One is, so one is due to this one, that is in this direction. And the other one is applied by this thing, right? And that is in this direction. But this force, right? This is applied by the body. So the forces when sign components are perpendicular opposites, they are not considered. No. Same forces for cosine component, no. So the forces which are applied by this object, that force we don't count. Every other force we count, right? But the forces applied by this thing, that we don't count. So that is the idea of free body diagram. We only count the forces which are acted on that system, not acted by that system, right? So this force we don't count, right? Usually, let's say if you have these boxes which are touching, right? So then this is applying this force, this is applying this force, right? So we will not count on this object, we will not count this force, which is applied by this thing. So this force will neglect, only will count this force. So that is how we write the free body diagram, right? Okay, so yeah, that was the idea that I wanted to convey. Now let us solve some other questions. And we have to quickly complete this one. So there are two questions, three questions more. We'll quickly do these and then we'll move on to dynamical circular motion, and that part I will derive, because that thing, if we derive that thing, that becomes very understandable, right? So if we derive that thing, the banked road and unbanked road, so if we derive that thing, then that becomes very easy to understand. Otherwise, there is always a doubt that what is the angle that we should take. So yeah, I will talk about that, but let us first complete these questions. So one is, right. So I was looking at the Aryan book, but they have solved this question. So some of the questions that are given in that book, so solutions are wrong. So don't go by that solution, right? Some of the solutions are wrong. So this question, and there was another question that I found. So those are wrong, right? So in this question, what do we have? We have an inclined plane. So we have this inclined plane. And now we can write every other forces, right? So let's say this is the object. This is the object which is going upwards. Going upwards, which means that this is the direction of acceleration. Right? This is acceleration. And if we write this is the angle of inclination, what is that? Angle of inclination is 30 degrees. So let's write theta as of now. This is mg. And this is angle theta. So always remember this is angle theta. So this is mg cos theta. And your axis is this one, right? I will talk about a scenario in which we take this axis, right? This is the axis that we take. And we will come across this thing very soon, right? So first let us understand this one. So this is the axis, right? So we have this component, this is normal. And then we have this component, right, which is mg sine theta. This is accelerating in this direction. So what is the direction of friction? What is the direction of friction? Friction is in this direction. So this is case first, right? This is the direction of friction. So now we have everything. Let us write we have to find this acceleration. That is the idea. So this part, vertical part is equilibrium, right? Vertical part is equilibrium. So N is mg cos theta. Now, okay, who will tell me what is the horizontal part? Tell me the equation of the horizontal part. What would be the horizontal? So remember, this started with the initial velocity. This started from here, and it started from initial velocity u equal to, I will write u equal to v naught. So yes, what would be the horizontal part, guys? What would be the horizontal part? Anyone? We have done so many questions. What would be the horizontal part for this case? You guys are not replying. What happened? In the earlier classes, you guys used to reply, but now you guys have become silent, right? Silent treatment you are giving. So F, right? All the forces that will add up to MA. And we know that both the directions are opposite. So MA would be minus of mg and minus of F. Right. What is this friction? What is this friction? This is Fk, right? Kinetic friction. So what would be this thing? MA is minus F minus, yes, absolutely correct. Yes, Maria, absolutely correct. So this is minus MA. Kinetic friction is mu K N. N is mg cos theta. So mg cos theta. M and M cancel. Oh, why did I write minus? So this is So this acceleration is minus of, you didn't add sine theta. Where is sine theta? Oh, yes. Yeah, so, oh, why did I write mg? Yes, yes, correct. Yeah, I made a mistake in here. So MA is, yes, correct, correct. Mg sine theta. Yeah, good, good. So this is Fk. So this is MA minus Mg sine theta and minus of mu k and n, which is Mg cos theta. So how much is this thing? M and M cancels, and A is minus of G, we can take common, and sine theta plus this is mu k cos theta. So what kind of acceleration is this? What kind of acceleration is this? Guys, tell me. What does this negative sign signify?
Retardation.
Retardation, right? Which means that if it is starting with v naught velocity, so it will lose its speed, and it will, at this point, it will become zero. So final speed will become zero, right? Because why? Because it is retarding, right? So we have initial speed, which is v naught, final speed, which is zero. So if we apply, let us write the values first, right? And I'll be back in a moment, right? What I will do is that I will, because if that time is here, so I will just write case second, and I will give this question to you guys, right? So now in the second condition, what is happening? Acceleration, so this is going down. Initial velocity is zero. This is going down. You have this mg, right? And then you have this theta, you have this mg cos theta, this is mg sine theta, this is ma, and this would be your friction. This is your normal reaction. So your n is mg cos theta, and I will write ma directly. I will write. So ma is mg sine theta and minus of fk. So Fk is how much? Mg sine theta minus mu k and mg cos theta, right? And this is cancels. So you have acceleration, which is g sine theta minus mu k and cos theta, right? The idea of this question is that your final velocity is v naught by 2, u is 0, your s is same. S is same, acceleration is changing. This is acceleration, this is retardation. S is same. So you guys have to compare these S and find out what is what. What is the kinetic friction, coefficient of kinetic friction. So you have to compare equal distance with different acceleration, right? And then get this mu k. So this is the idea, right? I have written everything. You guys solve. In the meanwhile, I will have my iftar, and I'll be back in 10 minutes, right? So yeah, you guys please solve this one. I have written everything, right? Every information you need, I have written it down. So please go through these, calculate, and find out what is mu k. Compare it with L by 1000, so you will get the value of L. So this is the question. Okay, one moment. Yeah. So calculate this thing, guys. I'll be back. One moment. Okay, so who has got the answers? Who has got the answers? 346 and 346. So Iyad and Maria both have got 346. Right. So L is 346 that Maria and Iyad they are getting. What about you guys? Fadil and Shahid, what about you guys? Okay, so let us see this question, right? So now we know both the acceleration, we know v, we know u, and we know everything, right? We know a as well. So let us put these values. So we know that v square minus u square, that would be 2as, right? In the first case, so this is 0 minus u square and minus of 2g sine 30, right? So the value is sine 30. So half plus mu k and root 3 by 2. So this is, and what was u? So u is minus minus cancels, and this is minus, this is v naught square, right? So this is this thing. And we have s as well. So this is half plus root 3 mu k by 2, and then this is s. So what is s? S is v naught square by 2g and 1 by 2 plus root 3 mu k by 2. So this is first scenario. In the second scenario, what do we have? We have v square, which is v naught by 2 square, minus this 0 square. And then we have 2 and g sine theta minus mu k cos theta, right? And then s. So this is again how much? This is g. Oh, did I miss g in here? G is common, right? G is common. So g is common in here. And we have half minus root 3 mu k divided by 2 and s. And this is v naught square by 4. Right. So what is s in this case? S is v naught square by 8 g, and then 1 by 2 minus root 3 mu k by 2. Right, so this is the answer. Then we have to compare these two things. So what do we have? We have v naught squared by 2g 1 by 2 plus root 3 mu k by 2, and then v naught squared by 8g, and this is, let me write it, 2 1 minus root 3 mu k, and this is again we can take 2 outside as well from this one. So this is by 2. This one will cancel. This is 4. Right, this is getting cancelled. This is cancelled. So what do we have? We have this thing 4 1 minus root 3 mu k, and then we have 1 plus root 3 mu k. Okay, this was a lengthy question, right? So 4 minus 4 root 3 mu k, and then 1 plus root 3 mu k. So this will go the other side, this will go the other side. So 3 is 5 root 3 mu k. So what will be this thing? This is 3 by 5 root 3 mu k. So what is this thing? This is root 3. Right, so this is root 3 by 5 And we have to multiply it by how much? So this is 1000, right? This is 1000, which means that we have to multiply this by 200, multiply this by 200. So this is 200, 1.73 divided by, this is how much? 1000. So how much is this thing? This is 6, and this is 4, and then this is 346 by 1000. So L is 346. This was, yeah, this was indeed a lengthy question. Right, but Yad and Maria, yes, you guys got the answer. And what about you guys, Fadil and Shahid? Is it clear now? Is
Yes,
it?
sir.
Yeah, so just quickly note it down. Quickly note it down, because this portion you guys have noted it down. We have to just compare the distances, right? Both the situations, they are covering same distance. So that was the idea of this question. Quickly note it down, and then we will solve the other question. So I guess I will talk about one question more, and then we'll see the dynamical circular motion. Yeah, Fadil and Shahid, whenever you guys have noted it down, please tell. Okay, noted. Fadil has noted. What about you, Shahid? Noted. Done. Good. So now let us understand the last question, right? And which is related with, let's say you have some object and you push through the wall, push it through the wall. Then it will remain at its position, right? But it can slip downwards. So what is the minimum force that we have to apply so that it doesn't slip downwards? So that is the force in this question that we want to calculate, right? So what is the scenario? We have this wall, right? And this is the object. And let's say someone is pushing this object in this direction. So force is in this direction. I should write in this way. So this is the force, right? Gravity is downwards, and this is the force. So this would be the normal reaction, right? Gravity is downwards. So what is the force that is balancing this gravity? What is the force? What is the force that is balancing the gravity? Otherwise, it will go down, right? There has to be some force which is balancing this gravity to keep this object in its position on the wall, right? You are pushing this object on the wall, and then this object is remaining at its position. So there must be some force which is balancing this thing. Otherwise, it will go down, right? So what is the force?
Yeah.
Yes?
The F source.
The F force, what did you say? I cannot hear you properly. Yeah. Yeah, please say it again. Sorry, I couldn't hear it properly. So this one, which one? F is in this direction. Yeah. F is in the right direction. F is in this direction. So if I'm applying this thing, so this will move this thing in this direction, right? I'm asking that what is the force that is balancing this? Yeah, so this force is pushing this object inside the wall, right? So which means that they should go in this direction. I'm asking that because the same force that is applied by this normal reaction. So normal reaction is the same force. Whatever force we are applying, so the wall is exerting the same force. That is the normal reaction. I'm asking that what is the force that is balancing? So you see that these surfaces are touching, which means that this is the direction of, so this is the frictional force. So frictional force is balancing this thing, right? So friction is the root cause that it is not falling, right? Due to friction, it is not falling. Otherwise, if it would have been a smooth wall, it would have been a smooth wall, so it will slip down, right? Whatever the force you apply, it will slip down. So if it is not rough, if it is not frictionless, then it will stick to the wall. And that is due to this friction. So this is the question that we'll do, right? So let us do this question and then we'll move on to dynamical circular motion. So this is the last part. I will give this question, or I will keep this question as your homework, because these kind of question we have done so far, numerous question we have done, right? So you guys please calculate or solve this one. And yeah, if you face any problem, we'll discuss this thing. But yeah, please do this problem. Okay, so we have to find out this thing. Okay, what happened? Hmm. So we have this similar question and we have to find out the coefficient of static friction between a wooden block of mass 5 kg and vertical rough wall is 0.2. So static friction coefficient is given. The magnitude of horizontal force that should be applied on the block to keep it adhere to the wall will be dash Newton. So this is the question that I was talking about. And this is an important question. So we have this vertical wall, right? And you have to apply some horizontal force. So this would be the normal reaction. And this is the friction that we were discussing. This is static, right? And this is mg. So this friction is balanced by this mg, right? So equilibrium condition in vertical part. So Fs is mg. And we know that in the horizontal part, what is balancing? So F is N, right? And we know that what is this Fs? This is mu S N, and that is mg. So mu S N we know, right? Mu S N we know how much is that? This is mg. Oh, what am I writing? Okay. Yeah, so this is F is N, right? So N we have to calculate. right? And we know that Fs is mg. So this is mu s and n, and this is mg, right? So because n is not mg, right? N is not mg in this case because this is not downwards, so n is not mg, right? We have to be very careful. So n is not mg in here. N is mg by mu s. So this is the value if you put this value in here. So this is, oh, what happened? Yeah. So M is how much? 0.5, G is 10, and this is 0.3. So this will cancel. This is 5, and this would be 25 Newton. So this would be the horizontal force that we have to apply so that it doesn't fall down. This block doesn't fall down. So is it clear, everyone? Yes, guys, is it clear?
Yes,
Yes.
sir.
Yeah, quickly note it down, and then I will derive the idea of dynamical circular motion, and then we'll do some questions. Yeah, quickly note it down, guys. So this is the horizontal part, this is vertical part, and both are equilibrium. Can we do one or two pulley questions? Okay, so yeah, generally in pulley questions, okay, I have to see. So yeah, let's say if you want to do a pulley question, right? Just quickly note it down, and then we'll do some questions, right? Yeah, noted, everyone. Okay, so Maria is asking for a pulley question, so let's just do a simple pulley question, right? And we will just write the masses, right? So let's say we have this pulley, right? And then two masses are hanging. Let's say this is 3 kg, and this is 5 kg, right? So then you have to find out what would be the acceleration. You have to find out what would be the acceleration. So quickly calculate this thing. Right, you guys know that this is going downwards because this is heavier, this is going upwards. So use right, use Newton's law of motion and find out what would be E. And in the next class, I will take some interesting pulley questions, and then we'll practice that one. So, but because this is coming into my mind, right? We did one pulley question earlier, and this is the simplest one. Yeah, calculate the acceleration, guys. What would be the acceleration? This is the pulley. And this is the rope. 2.5 meter per second square. So Maria is saying 2.5 meter per second square. Yes. What about all of you guys? What about rest of you guys? What is your answer? We have derived this relation, right? We have derived the relation, and what did we get in the last time? 2.5. So why there is a question mark in your answer? Yad. Yad is saying 2.5 and this. Remember, you guys, what was the acceleration? This was g m1 minus m2 divided by m1 plus m2. And we always write the heavier mass. So this m1 is heavier. Right? So if we apply this thing, this is 10, this is 5 minus 3 divided by 5 plus 3. So this is 10 into, this is 2, this is 8, this is 4, this is 2, this is 5, so 2.5. Right? And you can apply the Newton's law as well, right? So in here, Newton's law would be what? So you have tension, you have tension. So in this part, this is T minus 5G, right? This is 5A. And in this part, oh, so this is not T minus, right? So because this is downwards, so we have 5G minus T, that is 5A. In this part, we have T minus 3G, that is 3A. So if you use the Newton's law, then you will get this answer, right? But this is the formula that we get if we solve these two things. So either you use this thing or you can apply this thing. This is universal, right? This would always be true. But it may happen that this is not true for some times, right? So, yeah. Is it clear, Shahid and Fadil? Yes, guys, clear? Okay, so now, yeah, I will choose some of the questions as well, right? Pulley questions, I will take that. I'll find some question and then we can do in the next class, Maya, right? So I will pick some interesting questions from pulley as well, right? So that we'll do tomorrow. Okay, then let us understand about this dynamical circular motion. And we have, right, so what do we have? So in this part, we have to remember that let's say we have two conditions, right? One is banked road and then one is the unbanked road. So unbanked road and the other one is banked road. And you guys have to remember, let's say that this is some car which is moving in this road, right? So this is the road. This is the road and the car is moving in this way. So the car will have this normal reaction, this mg, right? Now, if I don't want this car to slip, so slipping means that let's say this is the corner of the road, right? This is the corner of the road and let's say it is moving in some circular road, right? This is some radius. So if you see that I don't want this car to slip. Slipping means that this is going in this direction, right? So what is stopping this car to slip? What is the force that is stopping this car to slip? Right, these are the tires, or these are the wheels of this car. So these are in contact with the surface. So these are applying some frictional force in this car. So you have this friction in this direction. This is the friction. So due to this friction, this car is not slipping. That is why you must have seen that in rainy days, right? In rainy days, there are lots of accidents in the corner of the roads because car slips, right? That is why you have those tires, those structure or different kinds of structure of those tires, right? So to increase the friction. So friction can be helpful sometimes, right? We have seen so many examples of frictions in which these are helpful. So to stop this car from slipping, friction is acting in this direction. This is frictional force, right? And let's say this is some circle. And this is the center of the circle. So what is the force that act towards the center? What is the force that act towards the center? Yes, centripetal force. Yes, absolutely correct. So centripetal force. So what is the force that is acting as the centripetal force? This friction, right? So this is, and you can write. So let's say this is what is the maximum speed with which you can move on this road, and so that you don't slip in this direction, right? So that would be equal to this frictional force. So this centripetal force, Fc, is equal to this frictional force, right? And we know that what is this frictional force? So this is Fc, and this is mu n, and we know that this n is mg, right? So this is Fc, this is mu mg, right? And we know that we have to calculate the velocity, the maximum velocity with which we have to move so that it doesn't slip, right? So what would be that velocity? That is mv square by r, and that is mu and mg. So this m will cancel, and you will get v max, that is root of mu rg. So that is the case for the unbanked road. This you guys have already learned, right, in your 11th standard. So this is the case for the unbanked road, right? And remember, in this question, we will always take the axis as this one. So this is the axis. Earlier, for the inclined plane, we were taking this axis. But we will see that what is the axis that we will take for the banked road. So now let us understand this banked road, right? So we have, now this road is banked, right? So this is with some angle. This is the road, and the car is traveling in this direction, right? This is the car which is traveling. So in this question, always remember that you have to take this as your axis. So this is your axis, right? And now you can see that your normal reaction is this one. So this normal reaction is with some angle. And this is theta, right? This is, what would be this thing? Right, this is the wheels of this car. So in this direction, because this would be slipping, right? This would be slipping condition. So what is preventing this slipping? That is friction. right? And if we consider that this is some part of the circular motion, so this is the circular motion, right? This is centripetal force. Okay, now we know that this is how much? This is theta, right? This is theta, this would be 90 minus theta. So this is our theta. This is our theta. And again, what do we have? So this is 90 minus theta. So this is theta. So if we can make this diagram, then all the other things would be simple. We have this axis, right? We have this axis, and there are two vectors. One is this one, and the other one is this one. So these are with some angles, and we have to decompose these vectors, right? Is this part clear, guys? Is this part clear? Yes, guys, is this clear?
Yes, yes, sir.
Okay, so now let us write this thing clearly in here. So we have this thing. Now we have this vector, and there is another vector, right? This is F, this is N, this is centripetal force, this is theta, this is theta, this is mg. This would be n cos theta, and this would be n sin theta, right? And then we have this F, friction. So friction will have also two components. One is this one, F sin theta, and the other one is this one. Where should I write this thing? So let me. This is F cos theta. So we have, right, in this case, we saw that only friction was providing the centripetal acceleration. Now you can see that normal reaction and friction both are providing the centripetal acceleration or centripetal force, right? So if we write the Newton's law, right? Not the Newton's law, we are only writing the equilibrium condition. So in vertical part, you have equilibrium condition. That is n cos theta is f sin theta plus mg. And then you have horizontal part. This is Newton, not the Newton's second law. This is centripetal force. So what would be the centripetal force? This is F cos theta plus n sin theta. So these are the two equations that you will get. And if we can reach this equation, then your answer becomes very, very simple. Right? So if I know this thing very clearly, then all of the answers I can write, right? So I will not solve this thing, right? You guys can solve this thing and you will find that the maximum speed. So V max, if you solve these two things, if you put FC as mv square by r, so if you solve this thing, you will get that this is rg and mu s plus tan theta, and then you have 1 minus mu s tan theta. So this is the maximum speed with which you can move so that you don't slip, right? So in the you saw that in the case of the unbanked road, right? If you have unbanked road, theta is 0. So theta is 0, then you will get mu rg. You will get the unbanked road condition. But if you have the banked road, then this would be the maximum permissible speed. But you can also have right. You can also have this Vmax without slipping, without this friction as well. You guys can see that because there is another force which is providing the centripetal force. So if, let's say, we don't have the friction, right? If we don't have the friction, if we want to save the wear and tear of the tire, right? If we want the tire of the vehicle to be safe, right? And we don't want to wear and tear the tires, right? Then that speed would be called the optimum speed. So that speed is called optimum speed, in which you don't wear and tear the tire. And that is the case when this mu s is 0. So you don't have the friction in the tire, right? But you see that if we don't have the friction, then also we can have this centripetal acceleration. And that would be provided by this n sine theta. And you will see that this is simply rg tan theta. So this is called the optimum speed, right? So in the banked road case, we have two speeds. One is this maximum speed with which you can, you don't want to consider the wear and tear of the tire, right? You don't bother about the friction. So then this would be the maximum speed with which you can move in that path, right? Without slipping. And but if you want to save your tire, right? And without this friction, you want to move in that banked road. So then that is called the optimum velocity. So is this thing clear, everyone? Is it clear? Yes, guys, is it clear?
Yes, sir.
Okay, so quickly note it down and then we will do some questions, right? So we'll do some question based on this one. Just note down this part. If the diagram is clear, then the rest of the questions would be simpler. Yeah, quickly note it down, and whenever you guys have noted, please tell me. Done. So Maria has noted. What about rest of you guys? Whenever you guys have noted, please tell me.
Done, sir.
Done. Okay, so let us do one question on this idea, right? There are other questions as well, but let me choose the right. So yeah, this one. So this is a very simple looking question, but it has some twists. So what do we have in this question? Right, we have mass and we have negotiating a turn on a 30-degree, theta is given, and road at maximum possible speed. V max, right, that they are saying, and without skidding is. So the normal reaction, we have to calculate normal reaction, right? So this is also not given, this is also not given. And we know that V max is root RG and then mu S. Mu S is also given, right? Mu S plus tan theta and 1 minus mu S tan theta. But can we apply this thing in here? Right, we don't have this important thing. So we don't have this R. In our case, in this question, they have not given the R. Right. They have not given the R. So we have to go back to our basics. So what was the basic? We have this banked road. Right, we have this banked road. And we know that this is gravity. Right. This is friction. And then what do we have? This is the centripetal force. And this is the normal reaction. And this is again theta. So what was the vertical part that we calculated? This was n cos theta. And this was theta. So this was f sine theta. Right. So what was the vertical part? Yes, guys, tell me what was the vertical part? What was the vertical part, everyone? Yes, guys, what was the vertical part? This is the just, yeah, that is why I showed you the diagram, right? That is very, very important. So what is the vertical part in this question? Yeah, what is the vertical part? Tell me, guys. Are you guys here? Yes, n cos theta. So, okay, so we have to write every equilibrium condition. Yes, the upward part in vertical part in the upward part is n cos theta. Yes, yeah, that is correct. And mg plus f sine theta equals to n cos theta. Yes, Maria, that is correct. So vertical part is showing equilibrium. So upward forces all the upward forces, that is equal to downward force. So if we write that thing, n cos theta is F cos theta plus mg. Right. Now, remember in this question, we have to find out what? We have to find out n. So we have this n, theta we know, f we can find out, right? So this is cos of 30. This is mu s and n, right? And this is cos of 30. And then this is mg, right? So we have to find out this n. Oh, why do we have 2 cos theta? This is sine theta, right? So this is f sine theta, right? So this is f and sine theta. Yeah, so n we have to calculate. Angle we know, mu s we know, g we know. So what would be that? This is n root 3 divided by 2. This is mu s. This is n. This is 1 by 2. And then plus m is how much? Mass is 800. And then g is how much? G is 10. Let's take 10. Right. So what is this thing? What is this thing? So n root 3 by 2. And then this is mu s is 0.2 and n by 2. And then this is plus 800. Right. And this is 8,000. So how much would be this thing? Okay, we have to. When we know that we have to take g equal to 9.10 or 9.8. So whenever it is not mentioned, then you take g equal to 10 and they will mention you that you have to take g equal to 9.8. And for both the cases, you will get the order of your answer, right? So order of the answer, that would be same. Yes. Oh, so Maria also already got the answer. So Maria is saying that option is A. Okay, let us calculate this thing. So how much is this thing? So this is, let's say this is, well, let's keep this 2. Right, so 0.2 and 2. So this is n root 3 by 2 minus n 0.2 n by 2, that is 8,000. So how much is this thing? So we have n by 2 common, root 3 minus 0.2, and this is 8,000. So root 3 is 1.73 minus 0.2, and this goes in this direction, so 1,600, oh, 1,000. And then n is, this is how much? 16,000 divided by, oh, so we have how much? 1.53, right? And they are seeing that we have to into 10 into, right? So we have to write this as 16 into 10 to the power 3 divided by 1.53. So how much is this thing? What is 16 divided by 1.53? Where is my calculator? Yeah, so what is this thing, guys? Can you tell me? Yes, what is this thing? Use the calculator, guys, and tell me what is this answer. 16 divided by 1.53. Where is my mobile? Yes, guys, please divide this thing. Use the calculator, use your mobile and tell me the answer. This is simple, right? 10.4. So this is 10.4 into 10 to the power 3 kg meter per second square, right? So this is 10.4. So the answer would be 10.4. So which is matching? So this one is matching. Right? This is of the same order. And as Iyad was saying, right? So if we take G equal to 9.8, then we'll get this answer. Right? If we take G equal to 9.8, then we'll get the answer. But the order is same. Right? This is 10.2, that is 10.4. This one is nearest to the answer. So this would be the answer. Okay, is it clear? Is this question clear, guys? We have just used the idea of these parts, right? So component wise, we have written this thing and then, yeah, we use that thing. So is it clear, everyone? Is it clear?
Yes.
Okay, quickly note it down and meanwhile, I will just get my right phone. You guys, only Maya told me the answer, right? So you guys, yeah, so quickly note it down and whenever you guys have noted, please tell me. And let me see what is 16. 10.45, right? 10.45 is the answer. And if we take, so let's check with 9.8. So 800 into 9.8, how much is that? So 800 into 9.8, that is 7840, right? So 7840. Okay, this much difference. Right. And then, yeah, and then we have to multiply this by 2. So multiply it by 2. So 15 and 680 divided by 1.53. So how much is this thing? 1 point or 15.6. So 15.6 into 68 into 10 to the power 3 divided by 1.53. So now let us check this answer. 15.68 divided by 1.53. So then you will get 10.2, right? Which is the option. So both the answers are absolutely correct, right? So you will get the same order of the answer. If you take 9.8 and if you take 10. But whenever it is not mentioned, then you usually take G equals to 10. So that is the idea. Quickly note it down, guys, and then we'll do a couple of questions. And then I'll start the new chapter, which is work energy and power. Yeah, whenever you guys have noted it down, please tell me. Yeah, whenever you guys have noted, please tell me. Yeah, noted everyone.
Yes, sir.
Okay, so now let us do another question, right? And that is based on this dynamics of circular motion. So, okay, let's do that question first. And then we'll do this question. So this question is very easy, right? You guys can write. So this question, yeah, we'll do this question, but okay, a block of moves at uniform matter with vertical side walls of the block. So let's do this question first, and then we'll talk about this one. So you see that this is unbanked road. And this is unbanked road, and you guys already know the answer of that. Yeah. But yeah, first let us do this question. Okay, so what do we have? A particle M is suspended from a ceiling and a string of length L. The particle moves in horizontal circle of radius R such that R is L by root 2. Then you guys have to find the speed of the particle, right? So we have to find the speed of the particle and what are the things which are given. So you have, right, this is, let's say, the fan. This is, let's say, right, this is the particle of mass M, and this is moving in circle. Right, so this particle is moving in this circle. And you have to find out what you have to find out. So you have to find out that this is your tension, right? This is angle theta. And so you have, this is angle theta, right? So this tension will have two components, right? This tension will have two components, and this is T cos theta, and this is T sine theta, right? And we know that what is this radius. So this radius we already know. This radius is L by root 2. Okay. Now, can you guys tell me? So we have this mg, right? So the vertical part is balanced. Vertical part is balanced by this tension. So T cos theta is mg, right? And in the horizontal part, what do we have in the horizontal part? Can anybody tell me? What do we have in the horizontal part? Yes, can you guys tell me what do we have in the horizontal part? Yes, guys, what do we have in the horizontal part? This is moving in a circle, right? So if you hang something and then rotate it, so centripetal force. Yes, Maria, that is correct. So we have centripetal force. right? And what is providing that centripetal force? This T sine theta, so sine component of tension, that is providing the centripetal force. So Fc is T sine theta, right? So this is what? This is mv square by r, and this is T sine theta. And you have mg, you have mg as T cos theta, right? So you have to get rid of this tension, right? So you divide these two things, dividing. So what you will get? This tangential will cancel, m and m will cancel, and you have v square by rg, that is tan theta. So what is this thing? So v square is rg tan theta, right? And do we have the angle? Oh. So what we can do about this angle? Can you guys tell me? Right. What we can do about this angle? We don't know this angle. So can anybody tell me what we can do about this angle? Yes, anyone? Because you see that we need this tan theta. So what we can do? We have the radius r, we know g. G, what is the g that? Oh, so g, we have to take g. So tan theta, how we can calculate this tan theta? Yes, guys, this distance we know. Length of the rope is L. This is 10th standard mathematics, right? This is L by root 2. So we have to calculate tan theta. Tan theta would be perpendicular by base, right? So we have to calculate this per base. Yeah, so 1 by root 2, oh, what is that thing? L by root 2, root 2, LS square, 1 by root 2, oh, what? Okay, so I guess you are saying that we have to find this thing, yeah. So this is base. So what is base? Base is hypotenuse square minus this is square, so L square by 2. This is root. So this is 2L square. Oh, these are same. Okay, so did I L square minus L square by 2. So that is 2L square minus L square by 2. So that is L by root 2 again. Oh, which means that, so this will cancel, right? So that would be, okay, so this is L by root 2. So both these are equal. Perpendicular and base are equal in a right angle triangle. When that happens? When that happens, when you have isosceles right angle triangle. So theta is 45 degree, right? Which means that tan 45. Tan 45 is 1. So what you will have? You will have v square as root of rg, right? And why didn't they put this value of r? Because r we already know, that is L by root 2, right? So this would be the answer. Is it clear, everyone? Is it clear?
Yes, sir.
Okay, so quickly note it down, guys, and yeah, then we'll move on. So I will then jump to the work energy and power, right? So I will quickly discuss some of the questions from work energy and power. Yeah, whenever you guys have noted it down, please tell.
Notes.
Noted. Okay, so what about rest of you guys? Noted. Good. So we'll quickly do this unbanked road question, and then we'll talk about the, right, so these questions. Okay, so let's quickly do this one. And then we'll talk about work energy and power, right? So you see that this is the road, right? This is the road of this modern Grand Prix. Racing car of Massem is traveling on a flat track in a circular arc. So this is the arc, and the car is moving in the circular arc. If the coefficient of static friction, the tires and the track is mu s, then the magnitude of negative lift FL acting downwards on the car is assume forces on the four tires are identical due to gravity. So we have to find out that what is the negative lift, right? So the car is supposed to be going downwards. The car is feeling that it is going downwards. So that thing we have to calculate, right? FL we have to calculate. So we have this car, right? This is the car. Let me choose the other color. So we have this circular track, right? This is the car. And we know that what is providing, right? This is not slipping. So what is providing the centripetal force? What is providing the centripetal force? This we have just done, right? What is providing the centripetal force? What is providing the centripetal force so that this is not slipping? Friction, right? Yes, correct. So friction is providing the centripetal force. So we know that friction is F, right? Now we know that how much is this thing, right? So we have this dynamical lift, right? What is this dynamical lift? So this is the normal reaction, right? And then you have this dynamical lift, which is downwards. And then you have this mg, right? So what would be in FL? FL is how much? So N is, right, N minus mg is FL, right? So we know that how much is this N? So FC is F, which is mu SN. So N is FC by mu S, right? And we know that what is this FC? FC is mv square by R, and this is mu S, and this is your N. So if we write this thing in here, so this is mv square by mu S R minus of mg, and this is your FL. So what would be this thing if we take this m common? So v square minus mu S R minus g, and this is your FL. So this would be, where is the option? V square by mu s r minus g. So this is the option. Is it clear, guys?
Yes, sir.
So if we know this diagram, right? If we know the unbanked and banked road diagram, then all the equation would become easy, right? So we have to just Remember the diagram, what is providing the centripetal force and what is slipping and what is sliding and all those things, right? So why didn't we take mg minus n equals to fl? Because this is not moving, right? We are so this has lifted, car has lifted, right? Or it has gone down, but it is not moving upward and downward, right? This is at equilibrium. So car is moving only in this direction, right? This is not moving in upwards or downward direction. Is it moving? That is equilibrium. So we have to apply the equilibrium, right? In here we applied the equilibrium. Is it clear? Because we are not assuming that the car is going upwards. We are assuming that it has lifted, right? And then, yeah, so that is why we are not taking that is why we are not taking the second law. We are not applying the second law. We are applying the equilibrium condition. Is it clear? Yeah. So quickly note it down, guys, and then we will move on to the next chapter, which is work, energy, and power. So this much, yeah, we will need in the laws of motion. So, and on Thursday, I will take a subjective test, right? So you guys, please prepare whatever we have learned so far, right? First 4 chapters, whatever we have learned so far, please just go through those chapters. I will take a subjective test, right? Not the objective one, we'll take, or I will take a subjective one. So I will prepare some subjective questions and you guys, yeah, just prepare that. Okay, noted everyone.
Yes, sir.
Okay, so yeah, so what is this next part? This is the next, right. So all these things you guys already know, right? So this thing I will not talk about, but yeah. So we already know that what is the work done? How do we define the work done? So this work done is always attributed to the force, right? So this is always attributed to the force. If you apply some force and then you displace the object. So if you apply some force and then you displace the object, then you have to right. So then you will do some work, right? And that is defined by this scalar or dot product. So this dot product is this, but this is applicable. This is applicable for uniform force, right? If you have a non-uniform force, let's say if F is depending upon some parameter, let's say function of S or time, then you have to integrate this thing. So then the work done would be F dot ds, right? So depending upon the kind of force, there are two types of work done, right? There are two types of work done, and this is what? So this is, yeah. So you have two kinds of force, uniform like this one, then you apply this F dot S. And if you have non-uniform variable force, then you apply this thing, right? And then the third option to calculate the work done is graphical method. So if fx graph is given, then area under that graph would be the work done. So whenever the force and displacement graph is given, So you have to just calculate the area under that graph. So this was about work, right? Work done you calculate using force. This force is of two types, uniform and variable. So if you have a uniform force, this is simply F dot S. If you have non-uniform, that is integral of F dot S. And then you have graphical method. Graphical method with FS graph. Right, I guess somebody got disconnected. So, okay, Shahid got disconnected. So yeah, we'll talk about this thing in the next class. But let us quickly just go through these, right? So then we have two kinds of energy, potential energy, kinetic energy. This is due to position in space and time. So this is mgh, and then you have kinetic energy due to the virtue of the motion of the object. Whenever the object